Okie dokie, friends, let's see. We're going to explain MVT and the conditions for its presence. We're going to start with some vocab. Local max, local min, critical point. So let's see. If I just draw some random curvy curve, something like that, you could probably identify where local max is and where local min is. So let's see if you can. Actually, I'll change my mind. This is on a closed interval. A, B, C, D, E. I drew that E weird, I'm sorry. F, and G. So now I'm going to be asking you, and it'll probably pop up, which one's the local max, where local min is, blah, blah. So, now that you've done that, because I'm going to assume that I added this question already, the local maxes are going to be at B and at F. The local mins are going to be at A and D and G. So a local max is a place where f of x is greater than or equal to f of c for all c in some interval ab. That sounds super fancy, but all that means is your y value or function value is bigger than all the function values around it in what one of my professors at one point called a neighborhood. So like if I look at kind of this open interval here, is b the highest in that open interval? Keep in mind it has to be an open interval because otherwise things get wonky. Because I can't say, okay, in say this open interval, we wouldn't even talk about it. Anyway, I don't want to confuse you. Local min, same idea. F of x is less than or equal to f of c for all c in some interval ab. So that's the lowest. No big deal on those. Critical point. Critical point, you may or may not know. That's where the derivative, I'll call it f prime, equals 0 or undefined. And it's not the best to say f prime because it could be any function name, but I made it f prime just for funsies. So, but it's where the first derivative is 0 or undefined. Those are critical points. Now, this is a slide that if we were in class, we'd spend a while talking about. So you should pause the video and you should think about what's going on and what up here is asking you to do. It's really important time to think and consider what's going on. So don't just zoom ahead with the video and be like, whatever, I'm just going to watch Mr. Butterworth do it. Because you can watch me do it, but that's not going to help you as much. So take some time and think about it. You should pause. Have you paused? If you haven't paused, you better pause. Because I'm going to start going. In 3, 2, make sure you pause, because if you didn't, you're just going to take away your awesome thinking time. And 1. Okay, so find the slope between the two endpoints. So that's this slope here. Pretend I actually hit that. So that's 96 minus negative 84 over 5 minus negative 5. So that's 180 over 10, which is 18. Find a point or points on the curve that share this slope. So find the derivative, f prime. I multiplied it out for you, so 3x squared minus 7. Figure out where that's 18. Through the magical world of algebra, you should figure out that x is 25 thirds squared. Is that right? Of course not. You need a plus or minus. So there are two different places. So approximately right here and approximately right here are two places where the slope at the point, the instantaneous slope, the tangent slope, is equal to the slope overall. You have to think about, this is the really important thinking time. Will this always happen? Or will there be a function where I can't do it? You should be thinking, are you thinking? So no matter what the function looks like, can I make that happen? And so the answer is, of course, we need some requirements. So for MBT, if f is continuous, and write down the fanciness, on an open interval and differentiable on the closed interval AB, then there exists, that means there exists, a c, that's some x value, in the interval AB such that f prime of c equals f of b minus f of a over b minus a. Now I love writing that down and using some of those fancy mathematical shortcuts of like there exists and such that and all that stuff. But now we need to actually say what it says. So this is saying the instantaneous slope equals the average slope on the interval, assuming that the function is continuous and differentiable. So first question is, as I look at this next one, is h of x continuous and differentiable? And it's a cubic, so yes. So the average slope, so you need h of 2 and h of negative 2. So 2 cubed is 8 times 3 is 24. 2 cubed is 8 times 3 is 24, but of a negative variety. So the slope's going to be up 48 over 4, so the slope is 12. H of 2 minus h of negative 2. 2 minus negative 2 is 12. So we need to know, where does the derivative become 12? So the derivative is 9x squared. And where is that equal to 12? So that's going to be at plus or minus square root 4/3.